If y varies inversely as the square root of x and y is equal to 2 when x is equal to 1/2, find the y value when x is equal to 2. So the first thing to understand is that y varies inversely as the square root of x. So let's underline that concept. And let's see how we can express it using an equation. So you definitely know that there will be a constant proportionality. We can denote it as k. And it says that the y varies inversely as the square root of x, right? So we know that there's a square root of x involved. But when the x increases, y should decrease, right? Because that's the whole point of the word inverse, right? Inverse means when the x increases, y will decrease, okay? So it's not going to be increasing at the same time, y and x. As x increases, y will decrease. As x decreases, y will increase, right? So in order to behave opposite, in an opposite way, you have to not multiply by the square root of x, okay? Because this means that both will increase at the same time. But rather, you want to divide by the square root of x, all right? So when you divide, notice that when you increase the x, the fraction, because k is constant, it's a constant number that we're going to find. So the fraction will decrease because when the denominator gets larger and larger, the fraction gets smaller and smaller. And the fraction value is the y value, right? So as x increases, y will decrease. And the other way around, as x decreases, the denominator will get smaller and smaller, so the whole fraction will get bigger and bigger, and so is the y. All right? So they work in opposite ways when you set it up right. So now we need to solve for k, and the only way to solve for this constant first is to use the fact that y is equal to 2 when x is equal to 1/2. So let's use that information and solve for k. So we're going to take 2 for the y, because that's given. And then we're going to take k, and we're going to divide it by the square root of the x. And the x in this case is 1/2 when y is equal to 2, right? So we can safely just write 1/2. All right, and I better write this bigger, because this is a whole fraction under the square root. Okay. So now notice that we can immediately solve for k by multiplying both sides by square root of 1/2, square root 1/2, square root 1/2. Okay, so if you do that, you cancel out the 1/2 on the right side and you solve for k. So the k value as a result is equal to 2 divided, so what is that going to be? So 2 times radical 1 divided by radical 2, right? Because we know that 1/2 under the radical is the same as radical 1 divided by radical 2, which is giving you 1/radical 2. Right, so this should give you 2/radical 2, which is equal to equal to radical 2. Okay, because if you rationalize the denominator, it's going to look like this. This is called rationalizing the denominator. When you basically have when you're applying the root of 2 to the denominator and to the numerator, this is called rationalizing, and what you should get is 2/radical 2/2, which is simply 2/2. That's gone. You get only radical 2 remaining. So the radical 2 is the k value that we found. Right? So the new equation, well, it's going to be the same equation, except we're going to have k now. So that's going to be what? That's going to be y is equal to radical 2 over radical x. Right? So that's the equation that we're going to use, and actually let me use another color for this. That's the equation that we're going to use now to find y when x is equal to 2. All right, so this is the final stage of this problem. We're going to use this equation to find the y when x is equal to 2, right? Because if we know the x, we already know the k value, which is radical 2, we can easily find y. All right, so what that's going to give us is what? Y is equal to radical 2 divided by radical 2, right? Because that's the x value, right? Because this guy, x, was equal to 2, right? That's why I'm indicating this in red. I substituted the x with 2. So as a result, this is equal to radical 2 over radical 2, 1. So y is equal to 1. That's your final answer. I hope this was useful and fun. Thank you so much for watching, and I'll see you in the next video.